Let's take a look at this cubic functions question. The question reads, the function f of x is equal to 2x to the power of 3 plus px squared plus qx plus 3 is drawn below. N, coordinates 2 and negative 9, and m are the turning points of f. G is the y-intercept of f, and a, b, and c are the x-intercepts. The question reads, show that p is equal to -5 and q is equal to -4. And when I see a question like this, I look immediately at the mark scheme. The mark scheme here is 5. So generally that would tell me that I'm going to be doing multiple calculations, maybe even a simultaneous. So the first thing I need to do is I need to look at the equation that I'm given. So f of x is equal to 2x to the power of 3 plus px squared plus qx plus 3. I see immediately that there's two things that we don't know, p and q. And so I'm immediately thinking that I'm going to be doing a simultaneous equation. So to start, I'm going to take this coordinate n and I'm going to substitute it into this equation. So n, so -9 is equal to 2, and then 2 to the power of 3 plus p, then 2 to the power of 2 plus q, then 2 plus 3. Now we simplify. -9 is equal to 16 plus 4p plus 2q plus 3. Now I'm going to equate everything to 0. So 0 is equal to 4p plus 2q plus 28. Now I need another equation. And what I can do is I can work out the derivative. So let's work out the derivative. So f prime x is equal to 6x to the power of 2 plus 2px plus q. And I can equate this to 0, and I know that the x value then is going to be 2. So 0 is equal to 6, and then 2 to the power of 2 plus 2p2 plus q. And I can do this because remember that if you take the derivative and equate it to 0, you get the x coordinate of the turning points. Let's simplify. So 0 is equal to 24 plus 4p plus q. Now since both are equal to 0, let's equate them. So 4p plus 2q plus 28 is equal to 24 plus 4p plus q. 4p can cancel. That means q is equal to -4. Now to solve for p, I can substitute this -4 value into any equation. Let's substitute it in this equation. 0 is equal to 24 plus 4p minus 4. 0 is equal to 20 plus 4p. -20 is equal to 4p. P is equal to -5. And here we've shown it. Let's look at question 9.2. Determine the coordinates of G, the y-intercept of f. Okay? So for 2 marks, let's look at how we can solve. So 9.2, my equation now is f of x is equal to 2x to the power of 3 minus 5x squared minus 4x plus 3. If I want a y-intercept, x must be 0. If x is 0, all of these terms disappear. That means y is equal to 3. Now the coordinate is going to be 0 and 3. Let's look at question 9.3. If it is given that 3 and 0, if it is given that C is 3 and 0, calculate the distance between A and B, the x-intercepts. Okay, so for this one, I'm going to show you how to do something called synthetic division. So we go back to our equation. So 9.3, 2x to the power of 3 minus 5x squared minus 4x plus 3. And that's y. Okay, now they tell us that C, which is an x-intercept, has a point of 3 and 0. That means that it is a root. So I can divide that into this equation using synthetic division. So the way you do synthetic division is you take the coefficients. So 2, -5, -4, and 3. Then we set up something like this. And we know that since we know C is a root and has a value of 3, we know that there's going to be no remainder. So this is how we do it. First, bring down the first value, 2. Then multiply. 3 times 2 is 6. Now we add. -5 plus 6 is 1. Now multiply again. 3 times 1 is 3. Then add again. -4 plus 3 is -1. Then multiply again. 3 times -1 is -3. Now we add. 3 minus 3 is 0. Now these here are going to give us the remainder, or the remaining factor. So we can factorize our original cubic function, x minus 3. This is from point C. And the balance is going to be 2x squared. The 2 is here. Then plus 1x. There's the plus 1. And then minus 1. And that is our original, now factorized. Okay? Now from here, we can factorize this trinomial. So x minus 3, then 2x minus 1, and then x plus 1. And from here, we can get our values. We know that 1 is going to be x is equal to 3, that's point C. Then the other one is going to be x is equal to a half, and that's going to be point B. And then the last one, x is equal to -1, and that's going to be point A. Let's input that on our diagram. That has a point of -1. This has a point of half. If they want to know the distance from here to here, the distance is going to be 1.5 units. So from A to B is 1.5 units. Okay, let's move on. Question 9.4. Calculate the x-coordinate of M, a turning point of F. So remember again, if you want to get a turning point, all you need to do is take the original cubic. So y, let's do f of x is equal to 2x to the power of 3 minus 5x squared minus 4x plus 3. If you want a turning point, take the derivative and equate it to 0. So f prime x is equal to 6x squared minus 10x minus 4. Then equate this to 0. So 0 is equal to 6x squared minus 10x minus 4. We can divide everything by 3. 0 is equal to, divide everything by 2, not by 3. So 3x squared minus 5x minus 2. Now we factorize. In this bracket, you're going to get 3x plus 1. Next bracket, you're going to get x minus 2. From here, we can get x is equal to minus 1 over 3, or x is equal to 2. We know the x equal 2 solution. That's point N. That means this solution must be point M. And remember, they just wanted the x value. Let's move on to question 9.5. Determine the x coordinate of H, the point of inflection. Now, if you want to work out the point of inflection, you take the second derivative and equate it to 0. So the second derivative, so f double prime x, is going to equal 12x minus 10. Now we equate this to 0. 0 equals 12x minus 10. 10 is equal to 12x. X is equal to 5 over 6. So that's what they wanted. They wanted the x coordinate. Now another way you could do this is if you did, you take the turning points, you add them and you divide it by 2. That's another option. You get the same answer. 10.9.6 rather, for which values of x will f be concave up? Now when we talk about concave up or concave down, you need to use the second derivative. So 9.6, for concave up, f double prime x is greater than 0. So we know f double prime x, we worked it out already. So 12x minus 10 must be greater than 0. 12x must be greater than 10. That means x must be greater than 5 over 6. And the last question, for which values of x is f of x times f prime x less than 0? Okay. Now, when we're doing a question like this, so f of x times f prime x is less than 0. Here, I prefer to solve it graphically. The way that we can solve this is by thinking of where is the function of f of x going to be positive and where is the derivative going to be negative. Because if we multiply them, we'll get a negative value. Also, we can do the reverse where we have a negative multiplied by a positive. All right, let's go to our graph now and let's input our values because we need these values. So the turning point, this was minus 1 over 3. Okay, and yeah, that's about it. So let's divide this graph up into sections. So there's a section here, a section here, a section here. I'm just basically using the turning points and x-intercepts. Okay. Now remember, the graph of f prime x isn't shown here, or the derivative of x. But we do know that the derivative is the gradient. So all we should look for is what direction is the gradient going. For example, here the gradient is going to be positive. In this region, the gradient is going to be negative. In this region, the gradient is going to be positive. So we can highlight that if we want. So here to here, f prime x is positive. From here to here, f prime x is negative. And then lastly, from here to here onward rather, f prime x is positive. All right. Now let's evaluate f of x. Now f of x needs to be, if f prime x is positive, f of x needs to be negative. Is f of x negative here? No, it's not. F of x is only negative here in this region. So that is one possible solution. So here you can see that it's negative. It's below the x, below the it's in the negative y-axis. So when x is less than -1, that is a possible solution. Okay. Next, let's look at the next region. Let's evaluate this section here. So in this section here, what we are looking for is if f of x is negative, if f prime x is negative, we're looking for where f of x is positive. So f of x is positive here, between here and here. So x must be between -1/3 and half. And in the last section here, f of x is greater than 0. F prime x is greater than 0. So where is f of x less than 0? F of x is less than 0 in this region right here. So the last one is going to be x must be between 2 and 3. So let me just highlight these regions again. So here and here. So these are the three possible solutions. Let's write them down. So x is less than -1. Sorry, I've written that wrong. X is less than -1, or x is between -1/3 and a half, or x is between 2 and 3. So those are our solutions. Of course, you could solve them algebraically if you wished, though it would be a bit more challenging, I think. Yeah, that's it. Hope you found it useful, and I'll see you in the next one. Thanks for watching.